I'm Mike James, and in this tutorial we're going to investigate whether the linear model is the best model to use for a set of data, and if not, then we're going to transform that data or try to linearize it with an appropriate transformation. We have an example here where somebody has counted the numbers seeds starting from the center of a sunflower moving outwards, and they've counted that in circle 1 there were 3 seeds, circle 2 there were 5 seeds, circle 3 8 seeds, up to circle 10 233 seeds. So we're going to record that data in the calculator. I've already done that to speed things up in lists and spreadsheets view, and you can see circle 1, circle 2, circle 3 and the number of seeds in each circle. So let's go to data and statistics and plot these points. I'm going to make the circle the independent variable and the number of seeds. I'll tab up the dependent variable, and you can see the points in this scatter plot lie on some sort of curve. I'm going to put the least squares regression equation in, so analyzed regression mx plus b, and this is the line of best fit, the least squares regression line, and there's its equation. Now, to confirm that this is not the best model to use, this linear model, I'm going to have a look at the residuals. So I'm going to hit Menu, Analyze Residuals, and Show Residual Plot. Now this appears under the previous plot, previous scatter plot, and you can see quite clearly that the residuals lie on a curve. There's a definite pattern to them. Now remember, the residual is simply the difference between the actual y value and the predicted y value that you would get from this least squares regression equation. Now we're going to apply a transformation to see if we can linearize the data so that we we can make better predictions from the least squares regression equation. So what transformation are we going to use? Well, I'm going to try using the log y to base 10 transformation. That is, I'm going to apply log to base 10 to all these y values, which is the number of seed numbers. Now to do that, I can do it quite easily in the calculator. I'm going to hit Control left arrow, go back to the lists and spreadsheets view, and put an extra heading in here, log seeds. And now I'm going to go into this grey cell, which is the formula cell, and put Control log, and you can't see it very clearly here, but down here you can see it quite clearly. So base 10, and in this empty box here I'm going to type in seeds. That is the heading of this column here. Remember, we're logging to base 10 these values, not the circle values. So there it is. I'm going to press enter now, and I get these values here. Now the calculator has given me the exact values, and I'd prefer them in decimals, so I'm going to change the settings. I'm going to go to File. You can do this on your calculator too if you get this problem. Document settings, and I'm going to change from auto calculation mode to approximate mode and make default. And now you can see I've got decimal values. So I've taken the log to base 10 of all these seed values, which are the y values. So the next step is to graph the circle numbers against the new set of values in this column here. So I'm going to jump back into data and statistics, hit tab, and again make the circle number the independent variable, hit tab again, and choose log seeds this time as the dependent variable. And there you have it. The points are virtually linear. They look like they lie on some sort of straight line, and we can get the equation of that line by going Menu, Analyze Regression, Show Linear mx plus b, and that's the least squares regression line, least squares regression equation of this particular line, which is the line of best fit. So let's jump back now to the main page, and I've taken a snapshot of the last plot, and you can see the equation there at the top. Now one thing you have to be very careful about when the calculator gives you this least squares regression equation, it will give it in terms of y and x, and you must remember that y is actually log of base 10 of y, because remember we logged the y values. So you need to write that equation as log y to base 10 equals, and the right hand side can remain the same. We can now use this equation, and I'm going to replace y by the number of seeds, and I'm also going to replace x by the circle, which represents the circle number. Now we can make a prediction from this equation here. Suppose we want to predict the number of seeds for circle 11, we just replace circle by 11. And we get this result here. Now we still can't just work this out because we have log to base 10 of number of seeds, and we can work out the number of seeds by going back to the calculator and using solve. So that's what I'm going to do next. I'm going to go into calculate mode and hit menu, algebra, solve, and copy this equation in. So it's control log. I'm going to make it to base 10. Now I'm trying to find the number of seeds, so I'm going to let that be a variable. I could call it x, and then it's equals 0.2094 multiplied by 11, and then plus 0.2746, comma, and then x. Let's press enter, and there it is. X is 378.443. So the number of seeds that corresponds to circle 11 would be 378.443, rounded to nearest whole number 378. Now remember, this is just a prediction, and we've actually extrapolated here because the number 11 is outside the given circle numbers 1 to 10, so in theory that result is unreliable. And that's the end of this tutorial.